Welcome, everyone. For today's prep, we're going to start looking at cost, revenue, and profit functions. And for today's prep video, we're just going to be looking at cost. And then we're also going to see something called marginal cost. All right, so first of all, we're going to start with the cost function. So in this section and in the next section, the scenario we're going to be working with is we're going to be a company or maybe an entire industry that produces and sells one particular item. And we're going to let variable X, we're going to use that to denote the number of items that are produced and or sold. So when we're manufacturing something and we're a company, among other things, there's three functions that we're interested in: the cost function, the revenue function, and the profit function. So the cost function is, the cost of producing X units of our product. The revenue function, R of X, is, it tells us how much revenue is generated by selling X units. And then our profit function is telling us what our profit is. So what profit we generate by producing and selling X number of units. And we'll talk more about these formula here for how to calculate revenue and how to calculate profit. But you can think of cost as how much money the company has to pay out. Revenue, on the other hand, is how much money the company brings in. So it's the money that comes into the company. And profit is the difference. So it's how much money they actually get to keep. So cost is really how much money they have to pay out in order to actually manufacture the things, the items. So, some common costs are like building expenses, material expenses, labor expenses, things like that. Revenue is just purely how much money the company brings in by selling all their items. And profit is the difference of these two. It's revenue minus cost. So it's how much money they actually get to keep. So all of the money they bring in, they don't get to keep all that because there were those costs that they have to pay out. So, if they sell 10 items, there were some costs incurred from, producing those 10 items. So they have to pay those out as well. So they don't get to keep everything that they bring in. So profit measures how much money they actually get to keep. All right. So we'll be talking about demand equations in class. So related to this is marginal cost, marginal revenue, and marginal profit. And these are just the first derivatives. So marginal cost is just the first derivative of cost. Marginal revenue is the first derivative of the revenue function. Marginal profit is the first derivative of the profit function. So we kind of introduce this special name marginal when we're talking about these kind of economic equations like this. And all it really means, we'll see an interpretation, but you can think of it as meaning just do the first derivative. So if you see calculate the marginal cost, just do the first derivative of the cost function. All right, so let's think about what these derivatives are actually telling us. So first of all, I think it usually helps to consider units. So what are the units of our derivative? Well, it's the units of the original function divided by the units of the variable. So in our case, the units of cost, this is usually going to be related to dollars. So it might just be dollars, it might be thousands of dollars, millions of dollars, things like that. So usually this is going to be dollars. And our units of X, well, X is measuring, in this case, X is measuring how many items we're producing. So X is the number of items. So our units here are going to be dollars per item. All right, so it kind of gives us an idea of what the units are for C prime. So it's telling us dollars per item. Now what's an actual written interpretation of this? So these marginal functions, what do they measure? Well, they actually measure how much our cost, revenue, or profit functions would change by selling or producing one additional item. So this is where that word marginal comes in. They're telling us what's going to happen next, basically. So if we were to increase our production or sales by one additional item, these marginal functions are telling us, kind of giving us a way to predict what would happen to our cost, revenue, or profit, how much those functions might change. All right, so let's actually try an example. So let's suppose that the cost of producing X items is given by this function C of X, and the units for C of X are dollars. So we have this cost function. C of X is equal to 0.005 x cubed minus 0.5x squared plus 28x plus 300. So for the first part of this, we want to know what is the total cost when production is at the level x equals 50. So total cost, that's what our cost function actually is telling us. So all we're gonna do is we're going to evaluate our cost function at x equals 50. So we want the total cost at x equals 50. So we're going to plug 50 into this cost function and just evaluate it. So wherever we see an x here, we're going to swap that out with 50. So when we do that, we get 0.005 50 cubed minus 0.5 50 squared plus 28 times 50 plus 300. And that's it. Now, if we wanted to, we could simplify that down. So this would be, something you would need a calculator for. So this function's a little bit more complicated. And it does simplify. Well, actually, let's write that down the line below. So it does simplify into 1,075. So one thing with these types of problems, just be careful with units. So if units are given, make sure you include units in your answer. So in this case, the units are given. So C of X is given in dollars. So our units here would be dollars. You could write it at the end like that, or if you want, put the dollar symbol in front. So the total cost from producing 50 items is this 1,075. All right. One interesting thing about cost functions is we can kind of break them up into two parts. So this is just an aside, not really part of the example, but this cost function, we can break this cost function up into two parts. So there's this plus 300, and then there's the variable parts here. So sometimes we call the variable part our variable cost, because this changes. This is the part that changes based on how many based on how many items we're producing. So this is the part with the variables in it. So this is the part that actually changes. And then this constant at the end, sometimes call this our fixed cost. So an interpretation for fixed cost is this is how much money we have to pay before we start manufacturing anything. So this would be things like buildings and machinery, things you have to have in place before you actually start the production. So not really necessary for this example, but an interesting thing to note here. All right, so for the next part, let's calculate the marginal cost when x is equal to 50. So for our marginal cost, marginal, again, the way we read that is it means derivative. So we want our marginal cost at x equals 50. So that means we got to calculate C prime and then plug 50 into it. And let's actually get a little more room here. So first, let's calculate the derivative. And again, that word marginal, just think of it as meaning first derivative. All right, so let's do our derivative. So we'll call our derivative C prime. Differentiate the first term. So we do our power rule. We'll take the 3, bring it down, multiply it with the 0.005, and that'll give us 0.015 x squared. Then we do our power rule on the next term. So bring the 2 down, multiply it with the 0.5. So that'll just give us 1. So we'll have negative x. And then derivative of the next term is plus 28x. And then that fixed cost term, when we differentiate it, just goes to 0. All right, so we got our derivative. So now we want to evaluate this thing when x is 50. So we're just, wherever we see an x, we're going to replace it with 50. So we end up with 0.015, 50 squared, minus 50 plus 28. And if we simplify that, let me double check here. What do we get? 15.5. All right, so what are the units going to be for this derivative value? Well, it's going to be dollars per item. So you can write it dollars per item. If you want to put the division sign in there, you can. If you want to write it, a lot of different ways to write this. So $15.5 per item. It's another way. All right. So now let's interpret this value. What is this value actually saying? So let's interpret this marginal cost. And what it's telling us is at a production level. So I'm going to write out the interpretation first, and then we'll talk about it a little bit. So at a production level of x equals 50, what marginal cost does is it tells us how much the very next item is going to actually cost us. So at this production level of x equals 50, the cost is increasing at a rate. And we know what that rate is. It's this $15.5 per item. So what we have here, we kind of did a few things. So we first calculated the cost of producing 50 items. So let's just kind of list out our items here. So there's the very first item we make, then there's the second item, then the third item, and the fourth item, fifth item, and so on. And we keep doing this until we get to the 49th, and then the 50th item, and then we're going to go one further, 51. All right, so we produced, in this problem, we were at a production level of 50. So in that first part of this, we investigated how much it would cost to produce items 1 through 50. So this is what the cost, when we evaluated 50, we plugged 50 in and got the cost. That's what it was telling us, is the total cost of producing all items 1 through 50 here. What the marginal cost tells us is it's telling us the cost of producing this very next item. So you can interpret the cost of producing that very next item, this to be our marginal cost at x equals 50. So another interpretation, one, the marginal cost is a rate, so it's a rate of change. So it's telling us it's increasing at a rate of $15.5 per additional item. But another way to think of it is the marginal cost or marginal revenue or marginal profit, once we've gotten all, in this case, 50 items out of the way, the marginal function's telling us what happens next. So we can interpret this C prime, this marginal cost evaluated at 50, to be the cost of producing the very next item. In this case, item 51. So assuming all items 1 through 50 have already been manufactured, the marginal cost tells us, well, what happens if we just up production a little bit? We added one extra item to our production. How much would cost go up? So how much is that extra item going to cost us? All right, so we'll be looking at more of these marginal functions in class, and we'll start to look at some optimization problems involving these. So we'll see you then. Bye-bye.